All right, so this one now is being recorded. I usually just get another one, so double check. So chapter 4 is about a polynomial, okay? And we know what is polynomial, right? The polynomial is basically looks like a P of x, okay? You have a sub n x to the n power, all right? And n minus 1 x to the n minus 1 power all the way to constant term, a sub 0, okay? This will be all integer, all right? So the one we learned earlier, like f of x equal to x plus 1, this one is called linear. Linear is part of the polynomial, okay? And then f of x equal to x squared plus 2, this one is called quadratic. All right, quadratic is also part of the polynomial. All right, and even I have an x. This one we call this is a cubic, right? Cubic is also a polynomial. Okay. I'm trying to get in. Let me go to get this admit. Okay, so polynomial is quadratic. Cubic is part of the polynomial. So as long as you have these power are all integer, okay, that is all considered a polynomial in this case. All right. And then if we have a degree of the 4, we call this one is a quartet, okay? If you have a degree of the 4, like f of x. If you have a f of x equal to x to 4, right? This one is called a quartet. All right. And the quartet, so, and then if we have x equal to x to the 5, we don't have a name for this one right here. We're going to just call this one degree of 5, okay? But degree of the 4, 3, 2, 1, we have a specific name for them, that one. So you will know, need to learn a little bit this specific name, because sometimes it says it's a qubit. You need to know what qubit is, right? And then when it says quartet, that means the highest degree is 4, okay? So look at this one right here. Choose the n behavioral diagram that best describes a function. All right, so this one is not in the ascending or descending order, right? We usually prefer to write down in a descending order. So before I do this one right here, I would like to write down this one actually is 1 over 8 x to the 4 minus 5 over 3 x cubed, and then plus 8. All right. So now we are in a descending order. This one, the highest degree is x to the 4. So this is called a quartet. Okay, quartet, this one is an even power. All right. So the first degree term, usually we call this one is a leading term. Okay. Why we call it leading term? Because this term determines how the graph will look like. Okay. So you know, like if you have y equal to x, this will be a straight line, right? And then if you have y equal to x squared plus 2x plus 1, you know, this one is gonna be a parabola. All right. And because this one is x squared, so, and then if I have y equal to x cubed, right? Y equal to x cubed, gonna look at something like that. All right, so this first term determine the whole thing, determine how the whole graph look like. when the leading term is an even power, it will look like a quadratic. Quadratic is an even power. So this will look like both facing up or both facing down. Okay, when it's even power. When it's even power. And this coefficient 1/8, 1/8 is greater than 0, positive. So positive will be both facing up. All right. So this graph will look at something like that. All right. We don't know how the middle look like, but that's how you look like in here. So if we go to choose this one, of course, D is the correct answer. Okay. If you do not know, of course, you can put in a calculator. Okay, let me just show you how to use calculator to graph this one. But you should know the character for all these. I mean, you can use the calculator to graph, but you also need to know how they look like in general. Okay, trying to run my calculator. Okay, so if I go to all of this in here. So we have this one is 8 plus, okay, 8 plus, I'm gonna just 1/8. One over 8 x to the 4 power, okay, and minus 3/5 x to the 3 power, okay, and then we can graph how this look like. All right, we hit graph and it will graph. Okay, so that is both facing up, as you can tell. I can adjust my Y a little bit bigger. All right, so that way you can see a little bit whole picture. All right, so that is how they look like, right? This one is both facing up. And because it's even power, so they go into the same direction, the beginning and the ending go into the same direction. All right, so look like a quadratic, but the quartic is not necessarily symmetric. With all the quadratic equations are symmetric, right? Every quadratic is symmetric around the line passing the vertex, but the quartic is not necessarily symmetric. Will the quartic be symmetric? Yes, some of them. If I only have an x to the 4 power, this will be symmetric, right? If I just graph x to the 4 power. All right, this is still a quartic, right? And this quartic, the red one, you can see this red one. Now this red one is symmetric around the y-axis in here. All right, but not all the quartic will be symmetric. So in general, the quartic is not necessarily symmetric along with the axis. All right, but the parabola will always symmetric along the line passing the vertex. Okay. All right, so that is giving you a little bit impression, explanation of this quartic. So you don't just look at the whole thing. You need to read the entire question before you choose that one, right? Because sometimes if you don't read it carefully, you might get the wrong answer. Okay. All right. Find the zeros of the polynomial function and state the multiplicity of each. Okay, so this one right here, we have a second one, f of x is x to the 6, okay? X minus 1, and then this is square x plus 2. All right, and what does the 0 mean? 0, that means you make a y equal to 0, right? And we have a 3 factor, 1, 2, 3 factors. So each factor can be 0. All right, x minus 1 square, this can be 0. x plus 2 can be 0. And we go to solve this one right here, right? Sometimes the people say, how do I solve this? Well, you have this, you take the 6th root, okay? You take the 6th root on both sides. And then this root and power cancel out, so I will have an x. And then 0 to the any power or anything, this is still 0, right? And then this one, you can see if I take the square root on both sides, okay? If I take the square root on both sides, I will get an x minus 1, right? And then 0 square root is 0. So x will be equal to 1, right? This one is minus 2 on both sides, so we have x equal to negative 2. All right, so you need to write down with the smallest 0. So where's my smaller 0? My smaller one will be negative 2, 0, and 1. All right, so that is the smaller zeros in here, okay? If I graph this one right here, x and y. Okay, my smallest one will be the will be the 0, right? And then let's see what I ask in here. With smaller 0 multiplicity, okay? So with multiplicity, my multiplicity for this negative 2, this is so my smallest 0 right here, so it should be negative 2. Multiplicity here is 1, right? Because this is only x minus 2 to the 1 power, okay? The middle 0, so the middle 0, which is 0, okay? That's the middle one, right? And 0, this multiplicity, so how do you get a 0? 0 is from here. All right, so this multiplicity is 6, okay? And the largest 0, so my largest 0 here is 1, right? The largest 0 here is 1. This is the largest one. And then the 1, so how did 1 come from? Well, that's from x minus 1 square. So this multiplicity will be 2. This is multiplicity. All right, and that is the zeros, okay? All right, so what is multiplicity 1 mean? 1 means R power, okay? This R power. R power, this will be crossing. All right, so this point, it will be crossing in here. And this multiplicity 6 is an even power. All right, this is also even power. It doesn't matter 2 or 6, they both are even power. So even power is called tangent or sometimes called touching, okay? Tangent or touching is the same. All right, so what does touching mean? That means right here, I can touch this one mouse bed, or I can touch this one from the below and the mouse bed. So this is called touching, or sometimes called tangent. All right. Okay, so if I graph this one right here, let's look at how many power we have. We have 2, 6 plus 2, 8, 9. So this is 9 power, so this is R power. So my leading term, okay, or my highest degree term will be x to the, this is all multiplied, right? If I cover 1 in here, and then I have an x squared, so this is x to the 6, x squared x. So this is x to the 9 power. 9 power is an R power, and the coefficient is positive, so you're going to be starting and ending at 1 and 3, okay? So this will be something like that, going to 2 different directions, because it's a R power. Look at that, y equal to x. Think about y equal to x. Y equal to x actually is an R power, right? And then this is a straight line, okay? Y equal to x is a straight line. So this is going to 2 different directions, okay? If I have a y equal to x cubed, it's also R power. And then this is going to 2 different directions. Look at that. All right, so this is the highest degree is 9 power. You're going to 2 different directions in here, okay? All right, and then what is negative 2? Well, negative 2 is, this one is R power. So at this point is crossing. So what does crossing mean? That means this one, crossing. All right, and then this is tangent, okay? Tangent in here. And then this one is also tangent, all right? So this will look at something like that. Okay, this is how the graph will look at something like that in here. All right, maybe I don't have a very exact answer, but that's how it look like. Okay, the graph will look like going to two different directions. All right, so that is how you answer this one right here, right? Any question about the second one? All right, so multiplicity basically is the power of each factor. All right, let's look at number 3. Determine whether the statement is true or false. Okay, and then you need to know why. All right, so this one, the graph of the polynomial is tangent to the x-axis and -2 and 0. All right, so number 3, we have a p of x. Okay, p of x is x minus 5 cube, x plus 2 square. Okay, so what is my zeros? Zeros, that means y equal to 0, or p of x equal to 0, right? So y is 0. That means y is 0. How much is my x? X minus 5 should be 0. X plus 2 should be 0. Okay? Or you can, if you want to put a cubic in here, that's fine. All right? And then you take a cube root on both sides, so this will be x minus 5 equal to 0, or x equal to 5, right? And the multiplicity here is 3, which is r power. R power, that means crossing at the x-axis. Okay? This one, you go to solve for x plus 2 equal to 0. X will be -2, right? And then this is an even power, even power. What does even power mean? That means it's tangent to the x-axis. Or sometimes we call touching to the x. Okay? All right, so we have y equal to 0, so -2 and 0. This one will be 5 and 0, right? Because y equal to 0. And then this one will be tangent or touching to the x-axis. Okay? This one will be cross. So if I want to make a graph, make a sketch for this one, how do I make a sketch? I have a -5 right here. I have a +2 right here. And then this leading term, look at this leading term, okay? Leading term here, this will be x to the cube. And then this is multiply x squared. So this will be x to the 5. X to the 5 is r power. All right, so this we are going to two different directions, like the one we just have earlier. Okay, also going to two different directions. And if I want to sketch this one, how do I sketch? Look at that. If I have a x equal to 0, what's my p of 0? P of 0, this will be -5 cube times 2 square. -5 cube will be -125 times 4, right? So this one will be, I think it's -500. So we really low in here. Okay, somewhere right here. All right, so at this point, this one is crossing. This one is tangent or touching. All right, so how do I draw this one? This will be look at something like that. Okay, hold on. 5 is crossing negative. This is negative. Negative, positive. So this should be negative, right? Oh, okay. So at this point is crossing, and then this point will be the tangent one. Okay, will be tangent. All right. Another way here is we can put this one in in a calculator. All right, we can put this whole thing in a calculator, probably more accurate that way. Okay, so I have a, let's see, what do we have? We have a x minus 5. Okay, x minus 5 to the power of 3. Okay, and then times x plus 2 square. All right, that's how you look at it. Okay, and then I will graph. Okay, so let me put a window a little bit lower. All right, so that's how you look at that. Okay, so this one is x negative 2. All right, I kind of, okay, I'm sorry, I put this wrong one. All right, I put a graph a little bit wrong one. That's why I couldn't make it work that way. Okay, so this one negative 2 should be right here, right? All right, negative 2 right here, negative 2, and then 5 right here. All right, so negative 2 here is touching. Okay, so when we come here and then touch and then come back. All right, and then we cross this one right here and then going this way. All right, now it works. Okay, 5 is crossing. This one is crossing. So y changes from negative to positive is crossing, right? And then this one is touching. Touching, that means I come in here and then didn't cross the x-axis and bounce back. All right, so that's how you look at that in here. Okay, you can see this one, that's how you look at that. All right, this one going up. Right, let me make y a little bit bigger. Okay, so you can see this one is coming down and then tangent to this one, tangent to the negative 2, right? And then cross the y-axis here, and then after this one, x equal to 5, this one is crossing. All right. Okay, so let's see what I say in here. The graph is tangent to the x-axis at negative 2 and 0. Yes, that is true. Okay, tangent at negative 2 and 0. So this one is true. Okay, and then let's say y is true in here. So the true here because the factor given the polynomial, the exponent 2 is even. So that's the graph tangent to the x-axis. I think for someone this got chopped. All right. So yeah, so this should be the correct one. Okay, this statement is true because this factor is 2. 2 is an even power, so the graph will tangent to the x-axis at negative 2 and 0. All right, and the graph will cross the 5 and 0 in here. The graph will cross this one. Okay, tangent to the negative 2 and 0, but crossing the 5 and 0 in here. All right, any questions? Okay, so graphing is polynomial graphing is very important for this part, for this chapter. Okay. Another thing here is you are allowed to use the TI 83 or 84 graphing calculator. If you really do not know, you can put in a calculator, graph them. Okay, so that will help you to answer the question. All right. Okay, so this one, f of x is x to the 10 power minus 7x to the 4 power plus 5x minus 1. You can see this one right here. This is an even power. The leading term is an even power, right? And the coefficient is positive. So if I will have a graphing, I guess I didn't print all the graph in here. All right. I think I missed this one. This part didn't print out all the graph because none of this. Oh no, that's number 4. Okay. Anyhow, number 4 didn't have a graph. All right. So number 4 here. for this function, okay, state that the maximum, so the A here is the maximum number of the real zero that function can have. Well, the maximum, okay, it's not necessary you will need to have that many real zero, but the maximum you have is the same as the leading term, the power. Okay, so this is the degree of the 10, right? So my maximum real zero here is 10. Okay, they can have a 10 or less, but they cannot be more than 10. Okay, and same thing, that means you have a 10 real zero, you also have a maximum of 10 x-intercept. Okay, and then the turning point. So what's the turning point mean? Look at this one right here. This is a turning point. So I have 1 and 2 turning point in here. Turning point, that means x changes from increasing to decreasing, and then this one from decreasing to increasing. So that's considered the turning point in here. All right. Turning point is always using n minus 1. The turning point, like say quadratic, right? All right, so the quadratic here, we know this is y equal to x squared. Okay, and then this is only one turning point because this is changing from decreasing to increasing. So 2 minus 1 is 1. All right, so turning point is always using n minus 1. So I have a 10 degrees here, 10 minus 1 will be 9. So the maximum you can have is 9 turning point in here. All right, questions? Okay, number 5, you want to sketch the polynomial function, and this one right here, like I said, I'm missing one of the graph in here. Otherwise, they don't have a correct graph for this one, right? Because this one is R power, coefficient is positive. This one is R power, leading term is R power, coefficient is negative. All right, this one is an even power, but the coefficient should be negative when you're facing down. Okay, so how does this one look like in number 4? Number 4, this should look something like that. Should look something like that. All right, with f of x equal to x to the 6 minus 4x to the 4 power. All right, so this is an even power. Leading term is an even power. All right, so even power, we'll go to the same direction. Okay, so that will be, look, this should be called answer D. All right, answer D. I don't show the answer D in here. But another way, you can also put it in a calculator, as we said earlier. If you really don't know, you are allowed to use a calculator, right? So I have x to the 6, okay, minus 4x to the 4 power. All right, and then graph them. So that's how you look at that. All right, in this case. All right, so they're both facing up in here. I am going to zoom to standard. All right, so that's how you look at that. Okay, with the 6th power, so they're both facing up. Okay, number 6 is sketch the graph of the polynomial. Okay, this one, let's see if we can sketch this one without using the calculator. I mean, you can always use the calculator to check, right? But one thing is here is we also need to try to see the character for this one right here. Okay. All right, so let's see how many factors. 1, 2, 3, 4. 4 factors. 4 factors here, that means they have 4 zeros. Okay, we have a x equal to 0. If you make this one equal to 0, x will be 3, x will be negative 3, and x equal to 6. They are all power of 1. So what does power of 1 mean? That means at all these 4 points, they are all crossing. Okay, they are crossing the x-axis in here. All right, so we can give you a little bit sketch. In here, 0, you have a negative 3, positive 3, and 6, right? So that's 1, 2, 3, 4. And they're all crossing, okay? All right, what is my leading term? my leading term here will be 1, 2, it will be x to the 4 power. Okay, x to the 4 power is an even power, so that means they're both gonna be facing up. All right. Okay, in order to calculate this one right here, I'm gonna go to calculate h of 0, trying to see how much h of 0 actually is also 0, right? So this is all crossing. All right, so that will be how you look at that in this case. So that's how we sketch. Okay, and how many turning point I have? I have a 1, 2, 3 turning point because 4 minus 1 is 3. Okay, so that's the most turning point you have. Sometimes you don't have that many turning point. Okay, but the maximum you can have is this one in here. All right, so now you can go to choose the correct answer, right? So this A looks the good one in here. All right. Like I say, if you do not know, you can put it in a calculator. Okay, so I'm going to graph a calculator for you. So we have a x times x minus 3, x plus 3, and then x minus 6. All right, we just didn't. So you have this whole thing that how it look like in here. It didn't look like that pretty, so you can adjust the window a little bit. All right, maybe I will let my maximum is 100 minimum, and then the maximum is 100. All right, so hopefully this will help. Yeah. All right, the graph will look much prettier that way. Okay, so they're both facing up. All right, so they got 1, 2, 3 turning point in here, and then you have 1, 2, 3, 4, 4x intercept, right? And they are all crossing in here. All right, so that looks like the one we sketched earlier, right? We'll give you a quick sketch. That's how you look at that in here. All right. Questions? Any questions? Okay, number 7. Um, we want to use the intermediate value theorem determine, if possible, whether the function have at least one real zero between a and b. All right. So a and b, a is -5, b is -4, and then you sketch select the correct answer choice. Okay. This one right here, I can show you how to calculate this one in a calculator. Of course, you can plug a equal to -5 in, b equal to -4 in, right? So look at this one right here. If you have one is positive, one is negative, that means how can you change it from negative to positive? That means they must cross the x-axis, all right? So since this one have qubit, so I'm going to just type this whole thing in the calculator, okay? And then plus 3x squared minus 9x, okay, minus 2. All right. And I'll show you how to calculate a specific value. Okay. I'll go to the main screen right here, and then I go to the bar using the y variable function. And since I put this one into y1, so I just put a -5. Okay. That way I will calculate this whole thing. When a equal to -5, f of the -5 is -7. Okay. And I can do the same thing for the -4. All right, and this one is positive. Okay, so look at that, between a and b, y changes from negative to positive. So that means this one must cross the x-axis. All right, so by the intermediate theorem, the function does not have at least one. No, that's not right. By the intermediate theorem, the function has at least one real zero between a and b. because f of the a, all right, we calculate f of a is negative, right? F of the negative 5, which is a, is negative, and f of the b is positive. All right, you can fill out in the number in there. That's how you look like. Okay. If you don't want to calculate this one, you can go to second table. All right, and then you can look at this one right here. Look at it. I have a negative 5. Okay, look at this one. When x equal to negative 5, y is negative 7, right? When x equal to negative 4, my y here is 18. So yeah, when this is integer, you can also look at the table for the value. All right. And I can graph this whole thing. Okay, I can graph this one since I already typed the function in here. And then you can see negative 5. So 1, 2, 3, 4, 5, negative 5. So this is below in here, below the x-axis. And then on 4, this is above the x-axis. All right, so that means between negative 5 to negative 4, right? Because you have 1 is positive, 1 is negative. So it must cross the x-axis in here. All right, any questions? Okay, number A here is a polynomial P of x and a divisor D of x are given. Okay, using the long division, find the quotient and the remainder using Px in the form of P of x equal to divisor times the quotient plus the remainder. Okay. This one is said using the long division. You don't have to use the long division. You can use called a short division or called a synthetic division here. All right. This is also called a synthetic division, which is a short division. Okay. The one thing is encourage algebra because the divisors are all linear. So you can always using the synthetic division. But when you got to calculus, your divisor is not always linear, so you must use the long division. Okay, but I'll show you both way, and then you can choose which one you want. All right, usually the synthetic is much easier and less mistake. But let's start with long division. So what does long division mean? 123 divided by 4. Okay, we can see how much is that. We see 123 divided by 4, right? So we have to use 12 divided by 4. So this should be 3. 3 times 12. All right, I'm going to give it another number. So not quite exactly equal to 133. Okay, something like that. 133 divided by 4. So I'm using 3. 3 times 4 is 12, right? And then subtract this one, you got 1, and then you pull the 3 down. Okay, and then you use the 3 again. Okay, if you use the 3 again in here, all right, 3 times 4 still 12, right? And then we have a remainder is 1, all right? So this one right here, I can using 4 times 33 plus 1. Look at that. Okay. So remainder 1 is not 0, so that means 4 is not a factor of 133. All right, so that is a long division in here. Okay, so very similar to the number we have before. In this case, how do I do the long division? My divisor here is x plus 3. I have an x cubed minus 27. The reason I put this 27 on the very end because we have to plus 0x squared plus 0x, right? Basically, that's how you do this one in here. And then we have an x. In order to become x cubed, I will need to multiply x squared. Okay, so x squared times x plus 3, you're gonna get an x cubed plus 3x squared, x cubed plus 3x squared. And then you have to do the subtraction. Okay, you always do the subtraction, just like the one we have in here. Do the subtraction. So this will be negative, this will be negative, right? And then these two will cancel out. So what's left here? 0 minus 3. So that's negative 3x squared. We don't have any x, so we're gonna using 0x. Okay. And now I have a x need to become negative 3x squared. So you always match the fourth term, always match the fourth term. All right, so x will become negative 3x squared. I will have to minus 3x, right? And then I will have a negative 3 times x, so negative 3x squared. Negative 3 times 3, so negative 9x. All right, remember you have to do the subtraction. All right, this is subtract, this will be positive. So these two will be canceled out, this will be positive. So I have a 9x, okay, minus 27. All right, and then x want to become 9x, so I will just plus 9, right? So x, so this will be 9x plus 27. All right, remember you have to do the subtraction, subtract everything inside, so these two will be canceled out. This is negative 27 minus 27, so this will be negative 54. So this is called a remainder, okay? Remainder in here. All right, so what's my quotient? Well, my quotient here, I can write down this whole thing equal to x plus 3 times the quotient. This whole thing is the quotient, okay? And then plus the remainder. Remainder here is negative 54, okay? All right, that's your remainder. All right, so looks like this one, yeah, it is a little bit long calculation. When you see this one, looks easy, but when you do that on your own, you have to be very, very careful. All right, otherwise it's easy to make mistake. Okay, I'm gonna using the synthetic method. So what does the synthetic method mean? Synthetic method is you write down x minus c equal to the divisor. Okay, so I will have to solve for c. How much is the c here? Is my c positive or negative 3, everyone? All right, are you still with me? Is c gonna be positive or negative? Can you type in the chat? Okay, will c be positive or negative? Anyone type it in the chat, or you can just say it out loud.
Negative.
Negative is the correct one, yes, because look at that, you have x cancel out. So you're going to have a negative c equal to 3, or c is negative 3, right? Or you can write down, this have to write down as minus negative 3 in order to have a plus 3. So c here is negative 3, all right? So if you want to do the synthetic division, you must find a c out first, okay? And then we have a x cubed, we need to write down in a descending order. So I have an x cubed into plus 0x squared plus 0x minus 27. So I will write down all the coefficients. So that's 1, 0, 0, negative 27. All right, so that's the synthetic method. You bring the fourth number down. So bring 1 down. All right, and then you start multiplying negative 3 times 1, you got negative 3. The good thing is this one you're using addition. All right, 0 plus this one still negative. And then you multiply again, negative 3 times negative 3, you got 9. Okay, and then negative 3 times 9 here, you got negative 27. So you add these two together is negative 54. So negative 54 is your remainder, same thing as we have in here. All right. So how do I write down my quotient? My quotient here will be 1x, 1 degree lower, since I start with the cube. So this will be 1x squared minus 3x plus 9. Look at that. 1x squared minus 3x plus 9. All right, so that is your quotient. Look at that. We have this one right here, the quotient. Exactly the same. All right, and then you have a same remainder. So this synthetic method here is much easier than this long division I just went through, okay? Look at this long division, it's much longer. The synthetic division here is much shorter. okay? All right, I want you to go ahead. Let's see. Let's try number 9. Trying to see if we can do number 9 on your own that way. So find out how much is the C here. How much is the C? C here will be -2 because you have x minus C equal to x plus 2. All right, so C here is -2. So I write down the, the number C on the side, okay? And this will be x cubed plus minus 3x squared. You have a missing term, you're gonna need to add a 0 in there. So that is your missing term is x, right? So I have a 1, -3, 0, and -2. All right, bring the first one down. And then -2 times 1, you got -2. The good thing is if you do the synthetic division, it's addition. You add these two together. All right, and then you start multiply this again. And then you got a positive 10, you add them together. And then -2 times 10 is -20, right? You add these two together. So you got a -22, okay? And what's my quotient here? My Q of x will be 1 degree lower. So this one is start with Q. So this will be 1x squared minus 5x plus 10. And we usually don't need to write down 1 here. So this just will be x squared minus 5x plus 10 for the quotient, okay? And my remainder here will be just -22. All right, so that is how you do this one right here. I'm showing you two different ways. Okay, one way is synthetic division, another way is called a long division. Usually you don't have to do the long division, even if said that, because you only need to figure out the quotient and the remainder, right? So the short division or the synthetic division work just fine. Okay, any questions? All right, let's look at number 10 here. Using the synthetic division to determine whether the number are zeros of the polynomial or not. Okay, so this is called a remainder theorem. So what is the remainder theorem? Remainder theorem here is if I find f of -2, it should equal to the same as this one. Okay, if I plug f of the -2 into the original equation, is giving you the remainder the same, like a -22. All right. Okay, so look at this one right here. See that the correct choice fill in the answer box to complete your choice. Okay. Using synthetic division, determine the number of zeros or not. You don't really have to do the synthetic division in here. You can use the remainder theorem, okay? If I just want to know is a zeros or not, I can plug it in. Three x cubed plus 11x squared minus 14x plus 30x. All right. Okay, I can actually graph this one to see what happened. Okay, that's a quick and easy one. Okay, so this like I only have a one real zero in here, not two real zero, but only one real zero cross the x-axis in here. Okay, all right. I can also go to look at this table. Look at the -5, x equal to -5, x equal to -5. The remainder is -84. Is not zero. Okay, so that means -4 is not a factor. Actually, if you look at this one right here, -4, y will be 0, so -4 is a factor. Okay, if you look at this one right here, this got exactly -4 in here. All right, and how about x equal to 3? Well, we can go to look at x equal to 3, go to the table, right? And when x equal to +3, let's see. When x equal to +3, my remainder here is 196. So yeah, -5, y is -84. So none of them is 0, right? -5 and 3, none of them is a 0. Okay. Because the negative f of the -5 is -84. F of the 3 is 196. Okay, so neither of these is a 0 for the polynomial. Okay, so now we're giving you the answer. -5 is a 0 polynomial, and it's not a 0. No, this is not the 0.
It's I think when you put the function in, I think you just put 14, not 14x. So
Oh, okay,
it's
okay.
yeah, it's kind of messed up.
All right, okay, my bad. Sorry. Oh yeah, that's right. I miss this whole thing. All right, I input this wrong. Okay, I'll take it back. That's 14x. All right, and then plus 30. All right, that's why. Okay. All right, so now this is graphing. So yeah, that's how the graph look like. So -1, 2, 3, 4, 5. So looks like the -5 is a 0 now, right? I can go to the table. I can go to the table. Oh yeah, look at it. Now this -5 is a 0. All right, sorry about that. I didn't input the function correctly to begin with. All right, I'm glad you found it out. That's why. Okay, and then +3. So let's look at +3. +3 here is 168, right? So this one is not a 0. Okay, so if you don't want to calculate one by one, you can just put it the function and then of course double check the function, which I didn't, right? Double check the function to see if you input it right. And then you can come to the table to do this one. Is much easier to have to input x equal to -5 and x equal to 3 into the calculation. Okay. The bonus for this one here is you can also graph. Okay. So I like this one. You can multi-purpose. You can graph, you can read a table, and you can find the answer from here right away. Okay, so yeah, a lot of benefit for input a function that way. All right, so yeah, the -5 is a 0 because f of the -5 is 0, right? So the remainder is 0, and the number is not a 0 because polynomial function f of the 3 is not 0. We already found it out. F of the 3 here is 168. Okay. All right, good catch for that one. Okay, let's look at number 11. Okay, this number 11 is on a section 4.4. Suppose a polynomial function is degree of the fourth with rational coefficient has the following given number as zeros. Find the other zeros. Okay, so what does the other zeros mean? One thing is in polynomial, conjugate is always a solution. Okay, so if I have a negative I, what is my conjugate? If you have a plus bi, conjugate is a minus bi. All right, so since I only have my a is 0 in here, so negative I conjugate will be just positive I. Okay, if you have a 3 minus square root of 7, conjugate would be 3 plus square root of 7. All right, so only I and the square root has a conjugate. Okay, if you have a plus bi, your conjugate will be a minus bi. If you have a c plus square root of d, your conjugate will be c minus square root of d. All right. So why is that? Because when you multiply the conjugate, you can get rid of I. When you have a square root, you multiply the conjugate, you can get rid of square root, right? Because look at it, a plus b times a minus b is equal to a squared minus b squared. So if I have a 3 minus square root of 7 times 3 plus square root of 7, my a here is 3, my b here is square root of 7. When I square this one, I got 9 minus 7, so I got 2. Look at that, 2 don't have any square root anymore. All right, so when you multiply the conjugate, you can get rid of the square root. If I have a negative I times I will get a negative I square. And I square is equal to negative 1. So this will become positive 1. Okay, so that means I is gone. All right, so that is the beauty of multiply the conjugate. Yes, you do have to simplify I square equal to negative 1 in here. All right, so that is the other 0. And if some people say, if I have a 3, does 3 have a conjugate? No, 3 doesn't have a conjugate because it didn't have an I or square root. Okay, so only I or square root have a conjugate in here. All right, so the other 0 here will be just I and I and 3 plus square root of 7. Okay, that is the only 2 zeros. Okay, find a polynomial number 12. Find a polynomial function of the lowest degree with a rational coefficient that has given the number as the sum of its zeros. Okay, so this one, what degree should this one have? The lowest degree. The lowest degree should be 4. Why I know this one is 4? Because the conjugate should be also the solution. Okay, so I already know square root of 3. I will also have a conjugate negative square root of 3. I have a 4i. I also know the conjugate negative 4i will be also the solution. All right, so how do I find this one right here? Okay, this is number 12. All right, so I will write down my P of x equal to x minus C1 times x minus C2 times x minus C4, and so on. Okay, so this only have a 4 degrees, so that is how I have in here. So we're gonna have a x minus square root of 3 times x minus negative will be plus square root of 3, x minus 4i, and then x minus negative 4i will be plus 4i. All right, so I will need to go to multiply all these one in and then find out my polynomial. Okay, we can multiply these two together. This will be a squared minus b squared. All right, and then remember this is multiply, and then I'm gonna multiply these two together. This will be x squared minus 4i squared. Okay, and then we're gonna go to calculate this one. Okay, this one right here will be x squared minus 3, right? Square root of 3 squared will be 3. And then this will be x squared minus 16i squared. All right. 16i squared is negative 1. So this will be plus 16. Okay. And then we can use x squared times this whole thing minus 3 times the second parenthesis. And then we can expand this whole thing to get a polynomial, right? So this will be x to the 4, 16x squared minus 3x squared minus 48. Okay? These two are like terms, so they combine them together. All right, so that is my polynomial in here. Look at it. Okay? This polynomial, if you go to solve this polynomial, they're gonna have these 4 solutions. Square root of 3, negative square root of 3, 4i, and negative 4i. You're gonna have these solutions. All right. Any questions? Okay, let's look at number, you have to expand the polynomial function, right? The polynomial function in the expanded form. Okay, so that's why you will need to multiply this whole thing and then simplify. So that's the final answer in here. Okay, number 13 here, list all possible rational zeros. Okay, so how do you list all possible zeros? If you have a function, polynomial function is a sub n x to the n power, right? All the way to constant, okay? Basically the rational rational zero. All right, possible rational zeros are using p over q, okay? This p is different. This is a little p. P is a vector of a sub 0. Q is a vector of a sub n, okay? So let's see what is my a sub n in this case. My a sub n here will be 17, right? And my a sub 0 here will be 2, okay? This one will be only 2. All right, so what's my possible zeros? Possible zero is P over Q. All right, so how do I factor A sub 0? Well, A sub 0, I can have only 1 or 2, 1 times 2 or negative. We usually just using positive and negative, right? And same thing, 17, there's no factor in here. So this will be only this one. All right, so everything divided by 1 will be still equal to itself. Everything divided by 17. Okay, so all right, so this will be 2 over 17. So yeah, 1, 2, 3, 4. 4 times 2 will be 8. 8 possible zeros. So you got 8 possible zeros. 8 possible zeros. Okay. All right, so you go to check this one right here. We don't have a 1/2 in here, right? So A should be the correct answer. Okay, only A is the correct answer. All right, you always need to simplify this final answer and do not repeat, okay? If you have something repeat, you have to get rid of them. Okay, any questions? How do you find a possible zero, right? You always using the factor of the first term divided by the factor of the leading term, okay? So you will simplify, okay, and do not repeat. If there's something already in there, you don't repeat them. Okay, let's look at number 14. Determine the domain for the function. All right, so what's the domain for this one? Rational function, right? 4.5 is considered a rational function. So what's a rational function? Rational function is using p of x over q of x. All right, both p and q are polynomial. Okay, just like this one. I have a f of x equal to 5x minus 4, 5x plus 35. Okay, so this one do not have a square root, but you only have a denominator. So I usually tell people this is a no, right? You cannot divide by a zero, a number. And then this is okay. If you have a zero divided by something non-zero, that's okay. That's equal to zero. All right. So this one will be a no. So that means 5x plus 35 cannot be equal to 0 because we make this whole thing undefined. All right. And then we go to solve for x. So minus 35 on both sides. So 5x will be negative 35 divided by 5. So x will be equal to negative 7. So when x is equal to negative 7, denominator will be 0. So that means we have to get rid of this one. Okay. And if you want to type it in the interval notation, so what is interval notation? Interval notation, that means you have to get rid of these points. So you have a 1 to the left, 1 to the right? Negative 7. All right, so this part will be negative infinity to negative 7, negative 7 to infinity, okay? Make sure you use the parentheses because if you use the bracket, you include 7 again, negative 7 again. All right, so must use the parentheses. Okay, so that is how you find a domain for this one. So just denominator cannot be 0. Okay, number 15 here, this is considered rational function. Rational function, we need to know how to graph them, and also need to find the vertical, horizontal asymptote. Okay. All right. So what's a vertical asymptote? Vertical asymptote, that means the graph cannot pass, right? So we're gonna look at number 15. R of x equal to 3 over x squared minus 49. And I can factor x squared minus 49. 49 is 7 squared, right? So this is a plus b times a minus b. Okay, so we factor these two in here. Since there's no common factor with the numerator, so x plus 7 equal to 0, or x equal to negative 7, when x minus 7 equal to 0, or x equal to 7. These are the vertical asymptote. Vertical asymptote. So what does vertical asymptote mean in here? That means graph cannot pass. Okay, negative 7, positive 7. I will draw a dotted line in here. Okay, these two points are the undefined points. So graph cannot pass these 2 points. Okay, you can graph, you can curve somewhere, but cannot pass these 2 points. All right. So the vertical asymptote, look at it. Using common to separate the answer is needed. You have to type it as an equation. Okay. So my vertical asymptote here, I will type x equal to negative 7, common x equal to 7. So that is using common to separate the answer, right? That's how you answer this one. Okay. So we do have a vertical asymptote. So the rest AB is incorrect, right? Which equation is the oblique of Rx in here? Well, what is the oblique asymptote? Oblique asymptote is on the numerator. Numerator degree has 1 degree higher than the denominator. So my numerator degree is kind of x to the 0 because x to the 0 power is 1. So my numerator degree is lower than the denominator. So we do not have an oblique asymptote. So the answer will be B here. We do not have an oblique asymptote, but we do have a horizontal asymptote in here. Okay. So what is a horizontal asymptote? The horizontal asymptote here will be using y equal to a over b. A over b has to be the same degree. All right. So I don't have an x squared in here. I can add a 0 x squared on the numerator. So I will make it to the same degree. So my horizontal asymptote here will be 0 over 1. Look at that. This is 1 x squared, right? And 0 over 1 is okay. That is 0. So y equal to 0 is the horizontal asymptote. What does that mean? Y equal to 0. That means the x-axis in here. This x-axis is the horizontal asymptote. Okay? All right, so horizontal asymptote, you're always using y equal to. Okay? All right, and then you can go to look at the graph. All right, which graph is the correct one? Unfortunately, the rational function graph is very unpredictable, so we really recommend you to use the calculator to graph them because this is more than one piece. Okay, unlike the polynomial, you can guess really well. Okay, this one you can't. All right, so we are using 3 divided by x squared. Make sure you do the parentheses. Okay, and I graph them. All right, so if this doesn't look that pretty, you can go to zoom to standard, zoom number 6. All right, so that is how you look like. So looks like you got 3 pieces of the graph, okay? And if I have to graph by hand in here, I can copy it on my hand. This will look at something like that, right? We have a 1 piece right here. All right. And then we have another piece here. Remember, vertical asymptote, they cannot pass, right? And then we have another piece. When x is 0, let's see, how does that look like? Okay, we have another piece is bending down, okay? And remember, this is Okay, so that will look at something like that. Look at something like that. All right, when x is 0, you can see how much is r of 0. R of 0 will be 3 divided by 0 squared minus 49, or will be negative 3 over 49. So it's not quite to the origin, okay? My x equal to 0, y is a negative number. That's why I don't touch the origin in here. All right. The graph, because it looks like a touching, but actually it's not, because if you put it this far enough, you should look at this one right here. Look at it when x is 0, right? When x is 0, this is negative 0.061. So it's very small, all right? But it's not 0, okay? And that's how you look at that in here. I think mine is a little bit easier to read. All right, so that is the vertical and the horizontal asymptote in this case, okay? For the vertical asymptote, actually is pretty straightforward. If you don't have a common factor, just make a denominator equal to 0 and solve for x. That's your vertical asymptote, okay? Horizontal asymptote, you make the numerator and denominator to the same degree, and then just using the ratio of the coefficient, okay? And then you can find a horizontal asymptote easily. Okay, number 16, list all asymptote of this function, all right? Choose the correct one, okay? So what are these asymptotes in here? Okay, so number 16, look at this one right here. We have a f of x equal to 6x cubed, okay? And then x squared minus 4. First, we have to simplify, not simplify, factor it, all right? So 4 is 2 squared, right? So we can have a x plus 2, x minus 2. This is using a squared minus b squared equal to a plus b times a minus b. I'm sure everyone should know this factoring formula, okay? All right, so my asymptote here, we do have a we do have a vertical asymptote. All right, so where's my vertical asymptote? I don't have a common factor with the numerator. So I do have a vertical asymptote. When x plus 2 equal to 0, x will be equal to negative 2. All right, so we do have a two vertical asymptote, x equal to negative 2 and x equal to 2. Do I have a horizontal asymptote y equal to a over b? If you go to look at the a over b in here, look at that. My highest degree here is 3, right? And I don't have a denominator 3x to the 3 power. So I can add a 0x to the 3 power. So I can have a same degree. And my horizontal asymptote will be 6 over 0. Look at it, 6 over 0. 6 over 0 is undefined, it's a no. Okay, this is a no, no. All right, so what does no mean? That means we don't have a horizontal asymptote. Okay, no horizontal asymptote. And then if you look at this one right here, why we don't have a horizontal asymptote? Because this numerator degree is higher than the denominator. So actually this one you have an oblique asymptote. Okay, you have an oblique asymptote. Or sometimes we call it a slant asymptote. Oblique or slant asymptote is the same. All right, so we don't have this one right here, but we do have an oblique asymptote, so we don't have a horizontal asymptote in here. Okay, so how do I find my oblique asymptote? We have to go to do the division. 6x cubed divided by x squared minus 4. All right, you can plus 0x squared if you want. Okay, and what is my quotient? In order for x squared become 6x cubed, I need to have a 6x. All right, so 6x times x squared minus 4. This will giving you 6x cubed minus 24 minus 24x. Okay, so we have a 6x cubed minus 24x. And then you do the subtraction, right? So these two will be canceled out. This will be positive 24x. 24x is degree is already lower than x squared. So this is a remainder already. You cannot do the subtraction anymore. So this y equal to 6x is the oblique asymptote. All right. So how many asymptotes do I have? I have x equal to -2, x equal to +2. Those two are the vertical asymptote, right? And I also have y equal to 6x is the oblique asymptote. So now you go to look at this one right here. Looks like a B is the only answer in here. Okay. And then you can go to choose the correct answer for this one. Okay. So I can graph vertical asymptote. Okay, let's see how do I graph this whole thing. Let's put it in here. All right, we have a -2, +2. So we have a two vertical asymptote. We have an oblique asymptote y equal to 6x. So how does 6x look like? That will look at something like that, y equal to 6x. Okay, and then go to see where the graph will gonna fit into all these pieces. So we need to use the calculator for that. 6x cubed divided by, okay, my denominator got two items, so need a parenthesis. If you have a one item, you don't have to use the parenthesis. But when you got a two item, you must use the parenthesis. Okay, all right. And let's see how the graph will look like. Okay, remember the graph do not graph the asymptotes. Okay, it doesn't graph the asymptotes. I'm gonna put my window a little bit bigger, so you might, sometimes it's too small, you might be able to see the entire thing. All right, so um, A, B, C, D. I think I missed one of the choice in here. Okay. 6x cubed divided by x squared minus 4. Okay, let me zoom fit to see what happened in here. Oh, yeah. This one has a little bit, so I have to go to zoom fit in here. Look at that. Because it's missing the two parts. Okay, so this one I'm using the zoom fit because otherwise, when I put an x too small and then y too small, it only graph the middle part, right? So look at that. This one is the looks like y equal to 6x. This is the oblique asymptote in here. All right, oblique asymptote. But the like I said, the graph it never graph the asymptote. If I graph this one right here, 6x, I'm just graphing this one to give it a little bit visualize. Okay, so that's my oblique asymptote. Okay, you can see this graph is kind of really regress to this line in here. This oblique asymptote. All right. So that is how the graph look like. Okay, so this one you might have to go to the zoom and then using the zoom fit. Okay, go all the way down using the zoom fit. So that way it will show the entire graph. Otherwise, sometimes you do not know how much your x and y going to be that way. All right, so using zoom fit is a good choice, that one. Okay, I think we have a couple more questions here is the inequality. Okay. Um, Number 17, solve the inequality in here. So how do I solve the inequality? Basically, if you want to solve inequality, you have to solve the equation first. Okay, so we have x squared minus 17x plus 6x. We have to solve the equation y equal, we solve y equal to 0. false. Okay, so make sure everything, if you have this is greater than 1 or greater than 2, make sure you move to the left hand side and everything equal to 0. So solve this one right here. Okay, how do you solve this one? You can do the factoring. Factor 66 into negative 11 times negative 6, right? That will give you positive 66. But if you add these two together, you're gonna get a negative 17. So yeah, that's how you factor. All right. So we have a x equal to 11 and x equal to 6. Okay. So 6 and 11. All right. This one, you don't have an equal sign, don't have a greater than or equal to 0. So this should be a circle, right? Because we don't have an equal sign in here. And I go to separate this whole thing into 3 intervals. All right. So first interval will be from negative infinity to 6. Second interval will be from 6 to 11. Third interval here will be from 11 to infinity, right? And then we're gonna say this whole thing, f of x is equal to x squared minus 17x plus 6t6. And then we're gonna go to pick a random number in the interval. So for this one, I'm going to pick a 0. Okay, so we're gonna calculate f of 0. F of 0 will be 0 squared minus 17 times 0 plus 66, right? And these are all 0. So 66 is greater than 0. So we are looking for greater than 0. So yes, this whole thing, this interval is the solution. All right. So for the inequality, we have an entire interval as a solution. Okay. And then the second interval, I might pick a 8. All right. Or I might pick a 10. 10 is easier to calculate than 8. Okay. I like the 10 better because 10 is still in the interval. So now I will have a 10 squared minus 17 times 10 plus 66, right? And then this will be 100 minus 170 plus 66. So you can see 166 minus 170. So you will 166 minus 170. So this will be negative 4, which is less than 0. All right. So this one is positive, this one is negative. So this one is a solution, this one is not a solution. So no, this interval is not a solution. Okay. And then we can go to check the number 3. I will pick, like I say, 20, easier to calculate. Okay. So this will be 20 squared, 17 times 20 plus 66. And then that's 400 minus 340 plus 66. So you can see this one is positive. It doesn't matter how much is that, you know, this whole thing is positive, right? And positive, yes, this is a solution. Okay, so where's my final solution in this one? Well, my final solution, I got 2 intervals, right? The first interval union the last interval in here. So it will be negative infinity to 6 union 11 to infinity. All right. Another thing here is if you want to visually check your answer, you can put this whole thing in a calculator. All right. So let me go ahead and graph this whole thing in a calculator. So we have an x squared, okay, minus 17x plus 66. And then I graph them. All right, so if you go to graph them, okay, I can zoom to zoom free or zoom standard left with one. For this one, zoom standard is in the up now. Window a little bit to the right. Okay. All right. So you can see right here, right? This part you have a 6 and 11 in here. All right. If you go to second table, you can see when x equal to 6, y is 0, right? And then another one is when x equal to 11, y is also 0. Okay. All right, so between 6 and 11, this graph is under the x-axis, so this part is negative. So this part is positive, this part is positive. All right, so that will match our conclusion in here. We have a 2 interval, these 2 interval, that is the solution. Okay, So that is how you do this one right here. I think I probably have one more or not. Yeah, one more last one. Okay, this last one here is the called inequality, rational inequality. So rational inequality and polynomial inequality is very similar. This one you just have to solve two critical value. Okay. All right. If this one equal to 0, the only thing can be 0 here is numerator. 3x equal to 0 is divided by 3x will be 0. All right. Critical value, I will have to find a critical value for the denominator. Even my denominator cannot be 0. But this is considered a critical value. You know why? Because if I have a positive divided by positive, I will get a positive. But if I have a positive divided by negative, I will get a negative. Okay, so denominator is also part of the critical value. So this one, I will have a two critical value, x equal to -4, x equal to 0. And x cannot be equal to -4. So this must be circle. X can be 0 because we have an equal sign in here. So the only thing can be 0 is the numerator. So x can be 0. All right. So same thing, I have three intervals. Check all the three intervals. Interval 1 from -infinity to -4. Interval 2 from -4 to 0. Remember, this can be 0, so using the bracket. Interval 3 from 0 to infinity. Okay, so 0 is the bracket. All right. So, and then we can go to check each one right here. Like I said, I can check f of the -5, okay, and plug it in. So 3 times -5 over -5 plus 4. Let's see what we have. We have a -15 minus -1 over -1. All right. And this is positive 15, which is greater than 0. All right. And then we want a greater than 0. So yeah, this one is the solution. Okay, and then same thing, check this one, the second one, I might check a -1. Okay, so this will be 3 times -1 plus 4, and that will be -3 over 3. So -1, which is less than 0. And we want a greater than or equal to 0. So no, this one is not a solution. All right, this one is a yes. Okay, same thing, you check this one, I might just check a 1. All right, so 3 times 1, 1 plus 4, and then that's 3 over 5 is greater than 0. So yes, this one is also the solution. Okay, so what is my final solution? We have a -infinity to -4 union 0 to infinity. You will include a 0 as a bracket because I have an equal sign in here. All right, so that's it. That is give a really complete of the chapter 4. Okay, of all these review question. We kind of overtime a little bit, but I just want to complete the entire review for the chapter. Okay. All right. Any questions? Let me go ahead stop the recording.